What's up, math scholars? It's a big day here in math class because it's our first video of the whole entire school year. Who's excited to learn some math today? Yeah! Okay, it's on there. Just a clap today. Woo, 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 woo! So, you do not need to write these steps down. We're just going to kind of talk about them. These are steps to solving an equation. Definitely want to deal with any parentheses you see first, distributing, etc. Combining like terms kind of go in that step 1 and step 2. You use adding and subtracting to get all your variables on one side together and all your numbers on the other side together. And you finish it off by dividing so that you can isolate for x. At the end, definitely would want to reduce fractions. I am not a picky grader. If you have an answer that's a fraction and your friend has an answer that's a decimal, I'm going to count them both correct. I'm not going to get mad if you use fractions instead of decimals or whatever. Okay? Go ahead and write down the first problem. It's a super hard one. All right, raise your hand if you have an idea on what we should do to solve this. Let's go with Madison. Perfect. And if everybody could put a -5 right here and draw that line across, it'll kind of organize what's going on the left-hand side and the right-hand side. And then 26 minus 5, of course, is 21. Pretty easy one to start with. Now, we're not going to check our work on every problem this year, but it's good practice if you're taking a quiz or test to check your work. So I'll show you how I check my work when I check my work. I put a big check mark to let people know I am now checking my work. I would put that 21 in for x, and I would see if it does indeed equal 26. And 5 plus 21 does equal 26, so we're good. We have verified that our answer works. Okay, so if you see check marks, that's kind of like me checking my work and verifying everything's okay. All right, go ahead and jot this one down. Raise your hand if you have a good idea on how we're going to start this problem off. Oh, let's go with John. Perfect. So somebody last period, actually my last 2 classes, said to add 12. Do you know how they got tricked? I think. Go ahead. What? Yeah, they saw that subtraction sign and they thought it went with the 12. The signs always go with whoever's after them, so it's actually a negative x and a positive 12. So good job not getting tricked on. All right, so that minus sign does go with the x. It's a negative x. Don't lose your negative. I call that losing your puppy. You don't want to lose your puppy. 30 minus 12 is 18. We do have one step further to go because we know what negative x is right now. We haven't quite figured out what x is. What should we do? Yeah?
Multiply it by -1.
Yep. You could multiply or divide by -1. They both would accomplish the same thing. I'll just go ahead and do a divide by. I think my work would look a little nicer. 18 divided by -1, -18. Okay. Right. Got another pretty easy one, but I put this up here so we could have the discussion that there's often more than one way to do something. This problem could be solved by dividing both sides by 4 or multiplying both sides by 1/4. They both give you the right answer. So let's vote. Who would probably divide by 4 if you were solving this? Who would probably multiply by 1/4 if you were solving this? Yeah, do whatever you want to do. Do it your way. It doesn't matter. We'll all get the same answer. We can all be friends. So I'll just do dividing. And we're going to get 6. Okay. So pretty simple. Let's look at this one. So super similar as far as having 2 choices right now. We could divide both sides by 2/3 or multiply both sides by 3/2. It's all going to accomplish the same goal. So let's vote. Who would probably divide by 2/3 if they were doing this problem? Who would probably multiply by 3/2? It's more. The vote was more split. Do what you like best right now, okay? And I'll do what I like best. I probably like multiply by 3/2 best. It's going to cancel me. And I know people like reaching for their calculators right now, which is fine. I never give a quiz and don't allow you the calculator, but I'll give you some mental math tricks. You could just do this mentally. 10 times 3 is 30, and then you could do 30 divided by 2, so it's 15. Or there's another option. You could actually start with 10 divided by 2. 10 divided by 2 is 5, and 5 times 3 is 15. So either way, you're getting 15, and you didn't need the calculator to do it for you. All right, we got our first two-step problem. So I'm sick of listening to myself talk, so let's get a student up here to teach this to you guys, okay? All right, hello, video people. I didn't make my student teacher record her voice because that might be scary the first time, but she got 6/7 and did awesome. She subtracted that 15 and divided by 7. All right, let's move along to this one. I'll start you off with step 1, and then we'll have a student teacher take it from there. Go ahead and copy it down. So step 1 on this one is definitely just kind of combining those like terms. I like to use colors when I do like terms. So I'll underline all my x's in pink, all my numbers in green, and then I'll go ahead and just add them together. 1x and 5x is 6x. 13 minus 8 would be 5, and that's going to give me 40. And then let's go ahead and just get a student up here to kind of teach you how to finish it off the rest of the way. All right, our student teacher did an awesome job. She got 35/6, so hopefully you got that at home if you're doing the video with us. All right. Opposite of a sum theorem. This is very, very tricky. I will actually do this one with you guys. It's anytime you have a negative out front and then a whole bunch of stuff in parentheses. It's called opposite of a sum. Do you remember from last year or the year before what has to happen here? Yeah. EJ, what does the distributing? Is it the 12? It's the negative sign. So this negative sign will distribute to here and here. It's almost like there's a -1 there. Don't get trapped and think you're distributing the 12. I saw a couple people trying to distribute the 12 today. The 12 stays put. He is unaffected. The negative distributes to the x, making it a -x. The negative distributes to the 10, making it a -10. And then go ahead and finish it from there all by yourself on your own paper, okay? Just for practice. So what we did learn, though, is don't distribute that 12. When you get to here, you can do 12 minus 10, and that gives me a +2. At that point, you can subtract the 2 to the right-hand side, giving you -x equals 0. It is tempting to stop there, but we're always looking for what +x equals. It's still 0. Even if you divide by -1, 0 is still 0. Okay? So a++ if you got 0. We'll do one more like that because the concept is so tricky. This one's a little more complicated the way the problem reads. It says, suppose g of a equals 3a minus, parentheses, 7 minus 5a. For what value of a is g of a 12? You might have heard of f of x back in the day, in Algebra 1, f of x, g of x. It's the same exact thing here. It's called function notation. It's a really fancy way of saying, for what value of a is all this stuff going to be 12? So we're just simply going to stick that 12 right here. And this is the equation I want everybody to solve. So go ahead and attempt solving this. Please remember, you're distributing the negative. You're not distributing the 3a. That would be a bad idea. All right, if you were curious what this answer was, it was a equals 19/8. If you want to see all the steps, just click on the slide with the notes in Polaris. I have all the steps on there. We are now at the trickiest situation of all, variables in the denominator. Dun, dun, dun. Anybody taken AP chemistry? They had some summer work, I guess, and there were some problems where you had to solve for variables that were in the denominator. I had a student emailing me. This is how you do it. This is how you get those variables out of the denominator. The best way to get a variable out of the denominator, since they're dividing, is just to use multiplication. So a quick multiply by x will get them out of the denominator. And then you're just going to solve for x normally by dividing that 20 to the other side. So 1 over 20 is our answer on this one. Okay. So that's the traditional math teacher way of doing this problem. I'm going to teach you the flippy flip way of doing the problem. Don't go home and say you learned the flippy flip way, because it doesn't make sense and your parents will think I'm crazy. But I'll show you how you can do this problem a little bit quicker with one quick flippy flip step. So the original problem was 1 over x equals 20. Don't you agree that 20 could be written 20 over 1? Yeah. So if you want to solve for x, all you really have to do is flip the left-hand side of this equation. That would be x over 1. And flip the right-hand side of this equation, 1 over 20. And you're done. It's the flippy flip method. You just flip both sides. Isn't that cool? Yeah. It's just a fun, quick way of doing it. It's not super mathematical and thorough, showing all the steps or anything. Well, let's go to a square root. All right, jot this down. I'll get some students to give me some ideas. All right, raise your hand if you have a good first step idea. Let's go with John. Yep, I love that idea. So let's subtract our 15 over, giving us 3x squared equals 27. I need a second step idea. Madison? Yep. And that gives me x squared equals 9. I need a third step idea. This is actually the last step. John?
Square root of 9.
Perfect. Oh, did you want to do that one?
Oh, no.
Did we just say there's 3 Johns in here? I know. John. We'll have to have code names. All right, John. Any of the 3 Johns. Anybody can answer this. If your name's John, you can answer. What's the answer? What do you think the answer is, John?
3.
What do you think the answer is, John?
3.
Anybody think they don't quite have all the answer, maybe? That's a hint? Yeah? Yeah, so -3 is also a possibility. Anytime you take the square root of a problem, you're going to want to put a plus minus out front, because there are 2 possibilities. Because -3 squared is also 9. Okay. All right, let's do a square. Any questions on that? Let's do a square root problem. This one. I need an idea for step 1. Sydney?
Subtract 6.
Love that idea. Alright, we're at a similar but different place than we were last problem. What's my second and final step going to be? Does Abby know? She's looking up like she might.
Would you have to square 12?
Perfect, she's right. She knew she had to get rid of the square root, and squaring is the only way to get rid of a square root. They are inverse operations that cancel one another. So, question though, Abby, is there going to be 1 or 2 answers? It's actually only 1. I was kind of tricking you, making you think. 12 squared is only positive 144, so that's the only answer. That's good. All right, let's move on to foiling. So for one ticket, what movie did people wear foil hats so the aliens couldn't read their minds? No one's seen it. It's a terrible movie. It's called Signs. But every time I teach foil, I think of them wearing their foil hats because it was so funny. Other than that, the movie was terrible. So anytime you have a binomial getting multiplied by a binomial, let me show you what a binomial is. This is a binomial. So let's say I'm taking a binomial and multiplying it by a binomial. I would want to use the foiling method. So it's an acronym. Do you remember what it stands for? Just shout it out. What's F stand for? Good. What's O stand for? What's I stand for? And what's L stand for? And I do the rainbow method when I do this. Oops. Where'd it go? Oops. I lost my slide. It's lost. It's lost for sure. There it is. Okay. do the rainbow method. So when I say first, I draw a rainbow from the first term to the first term. And I'm multiplying those. M times M is M squared. All right, when I get to step O, I do another rainbow. I'll use a different color. I draw my rainbow from my outer term to my outer term, and I multiply those. So M times -4 is -4M. For I draw a rainbow from my inside term to my inside term. That would be 5M. I haven't used pink yet. +5 times -4 for my last rainbow, -20. And foiling is pretty cool because you normally have like terms, not always, and they are normally the middle two. So it's M squared plus 1M when you would add together a -4 with the +5. And then that -20 at the end. That's a -20 right there. You remember on foiling, you did it at the end of last year, hopefully?
Mhm.
Yes, yes? You want to try one foiling problem all by yourself? How about you guys do that foiling problem all by yourself? Your first rainbow is your x squared. Your outside rainbow was -2x. Your inside rainbow was 8x. And your last rainbow was -16. Those two together, 6x. Cool? Thumbs up. Are you remembering this stuff? All right. Okay. I should just pause this and reline the board up. All right, I do have these boxes here. You might be curious why we have these boxes here. I want to show you that the boxes are one other way to do these problems if you hate the rainbow and the foiling method. Since it is Algebra 2, we probably will be doing the rainbow and the foiling method. But I want to open your eyes to the box so you remember how Punnett squares work. Because we are doing a factoring method called the box method later on, maybe next week. So you're going to set yourself up a 2x2 box. The content of one of the binomials goes along the top. The content of the other binomial goes along the side. And it's just like filling out a Punnett square in biology class. So the content of this box we will get by multiplying the 3x times the x. So that would be 3x squared. To get the upper right box, we will be multiplying the x times the 7. We'll be getting 7x. Hopefully you see how it's working like a Punnett square. -3 and 3x is -9x. That's a negative sign there. And -3 and 7 is -21. Now what's pretty cool about the box method is normally your like terms do sit diagonal. So you would add them up to get your final answer of 3x squared minus 2x minus 21. Any questions on that one? All right, we'll do one more problem and then call it a day, and it's a bit of a challenge problem. For those of you math scholars in the room, super scholarly people, Sydney will get this one for sure. Maybe. No, this Sydney. Because she was my math scholar last year, and I know I taught you how to do it. Do you remember Izzy from your class? She remembered. I picked on her and she remembered. It's gonna do it. It's gonna go back again. Sorry. This one here. So this is officially the challenge problem. There was a foiling problem that generated this answer, and we have to figure out what that foiling problem was. So think about that for a second. We'll see if anybody can figure it out. All right, just finishing off my video, we did have several people come up with the answer. It's x plus 2 times x plus 8. 2 and 8 were our numbers that would multiply to give us that 16, and in addition add up to give us 10. So thanks for watching our first video this year. There is no homework other than to bring your calculator tomorrow. Talk to you later.